Okay, 7D. We are now looking at a convex mirror. Okay, with a P, or the object distance, of 5 centimeters, a focus of 2 centimeters, and the height of the object being 2 centimeters. First part, let's draw our mirror and its setup. So let's pick out a horizontal line. Let's do a vertical line. Let's draw my 5 centimeter P. Also, you know, if you really want to measure, I am scaling it a little bit just so you can see it so it's not too small. Technically I'm doing it in inches to centimeters, but not a big deal. Okay, now I need to get my focuses. So my first focus is at 2. And this is how most people draw this originally. But I cared about what type of mirror it was. This is a convex, so my mirror goes this way. The mirror goes this way. There is no time that light's going to be focused on this side. So this is not the focus that I want. The focus is actually going to be on the curved side, or the interior side. The focus I want is here. Another way to predict that is when you do your first ray. First ray follows our first set of rules. It comes in horizontal or perpendicular to the mirror. Now, I draw this curved line to track it myself. If it hits this, it is going to bounce up for a mirror. If it bounces up, I want to know at what angle. Well, it's according to the focus. So the actual bounce up goes like that. That's my first ray. So I use this focus to figure out that angle. It's another way you can figure out what focus it is. Second ray. Second ray aims at the focus. Now with mirrors, we use only one focus. So I'm going to aim at the one that I was using. Bam. Now, don't continue this line. As soon as it hits here, it is going to reflect, and it is going to bounce back perpendicular to the mirror, or parallel to the horizontal. Now, this bounce back line and this line will never meet on the left side of my diagram here, or right side to you guys. So I need to put an imaginary line. Cool. I need to go back now. If I drew the imaginary line for 1, I got to go back to ray 1 and draw that imaginary line. So we line up. Cool, lost my F in that, but that's okay. And then I still have my third ray, which is going through C. Now since I'm using this focus, I want to use C that's on the same side. So C's right there. Maybe more dynamic color, but oh well. So bam, bam. Now C, once it hits, is going to reflect directly back on itself, but the imaginary line comes in here. And that gives me a triple point of right about there. Okay? So, let's go to our answers over here. Let's see, is it a real or virtual image? Well, it's on the side where light never gets to. It's dotted lines, meaning that's not the real beam of light. The answer is virtual. It is the same direction in it, so it is erect. Q. So I can measure Q. Okay, if I measure Q, that's 2, probably about 1.6, 1.7. And the height of the image, so this was 2, well, I would say this is at 0.6 itself. Not really on the small side. Maybe a little bit less than that. You know what? I don't know. I'm really not using graph paper being accurate. So I'm going to check through calculation. I'm going to do my 1 over P plus 1 over Q equals 1 over F. Okay, so what is my P? Well, my P is 5 centimeters. I'm trying to determine and verify my Q, so I'll leave that as a variable. And F is 2. Now, in the last video, I talked about positive and negative F. The F that I used was this one, and that is on the side that is always imaginary, not the real being. So this is going to be negative. Okay, and so we solve this. 1 over Q is equal to negative 1/2 minus 1 by 5. Q equals. So let's just punch these on the calculator real quick. I get an answer of 1.42. That makes about sense. Graph paper would have probably shown you that we got that. I said it was 1.6, and I would actually then relook at my lines. So if I had this big of a variance, I would remeasure this just to make sure that I'm exact. Okay, and I would probably say that this line right here was a little off. Okay, and I would then see if that corrected it more toward the calculated number. Yeah, 1.42, 1.43. Cool. From here I can do magnification. Sorry, this would be still negative because it's on the negative side. Magnification is equal to negative Q over P. So negative 1.42 all over P, which was 5. So that gives me a magnification of 0.286. 0.286 times the height of my object of 2. Gave me 0.57. I said it was 0.6. I'm pretty darn close. I like that. My mathematic numbers match my drawing. I'm probably right. In fact, in this case, as long as I put my units, I'm now 100% right. It's nice enough.